Blue Origin is about to reuse a New Glenn booster for the very first time and is attempting a landing on their drone ship once again. Dream Chaser has been blasted with the sounds of liftoff for testing, while Virgin Galactic progresses with its new spaceplane, and Vast levels up spacecraft docking systems for even bigger space stations. As always, we've got all of that and much more coming up this week in Spaceflight. We're starting the show with the latest in fashion, but don't worry, this is still a show about space, as we're talking about the flight suits that astronauts might wear to future space stations. Vast, who is building one of these stations, has just revealed their astronaut outfits, and it doesn't just look great, but also seems very practical. And there's some other large news from Vast we need to discuss as well, and it might just be the thing that will make giant space stations possible. In case you need a refresher, Vast is building a space station called Haven 1, which they hope will be the very first commercial space station, and it will if they hit their targeted launch date in the first quarter of next year. The station's goal is to help Vast gain experience operating space stations and is designed to house a crew of 4 for a 2-week mission, with a total of 4 missions planned for its lifespan. Haven 1's lessons will then feed into the multi-module Haven 2 and beyond. So where does the suit come in? Well, Vast designed the flight suit for its astronauts to wear on the station, but also on Earth during training and other events. So it won't just keep the astronauts comfortable on Haven 1, but it actually might become the main uniform we'll see Vast astronauts wearing before, during, and after their flights. Now, its fashionable design might be deceiving. It's not just looks. In fact, the company used input from actual astronauts to ensure it's as functional as possible. The jacket and trousers have zips everywhere, and many pockets and hook and loop fasteners, or Velcro for attaching things. One interesting feature are the boots. In space, astronauts usually just wear socks. There's nothing to stand on. Perhaps they will only be used on the ground? We'll see. But why design such a suit at all? Astronauts on the International Space Station often just wear regular clothes. Vast wants the flight suit to be comfortable, practical, and protective, so the astronauts actually want to wear it. And we'll get to see a comparison next year, as the crew of Vast's private mission to the ISS will also wear the suit. That wasn't the only news from the space station company though. This week they also revealed a new docking mechanism for connecting spacecraft together. It's a huge upgrade, quite literally. Currently, the crewed spacecraft that visit the US/international side of the ISS use the so-called International Docking Adapter, or IDA, to connect to the station. That adapter is based on the International Docking System standard. It has a long history that goes all the way back to the Apollo-Soyuz test project. The design implemented for the first in-space meeting between the United States and the Soviet Union was iterated upon and later turned into the APAS-95 system, which the shuttle used to dock to the Mir space station. The same system made it onto the ISS and was later adapted to the docking adapter now used by Dragon and Starliner when visiting the station. NASA's implementation of this latest standard also features the Orion capsule, and the Indian Space Research Organisation has also adapted it for India's Gaganyaan program. In short, that means these capsules could connect to the same space stations. In theory at least. But, as Vast points out, the IDA has a rather limited diameter of only 80 centimeters, so you can't really fit large pieces of equipment through. Now, this is solved on the ISS by the Common Berthing Mechanism, which has a much larger opening of 1.6 meters. But that's a berthing adapter, not a docking adapter. The difference between the two is that docking means the visiting vehicle connects itself to the station, whereas berthing is a more passive process, for the visitor at least. In that case, the station grapples the spacecraft with its robotic Canadarm and carefully moves the craft into position. This works really well, but it's not great for crewed vehicles, it's too slow for an emergency, and depends on the station infrastructure to be working. So Vast is trying to solve these issues by taking the next step, or rather a giant leap. Their new docking adapter dwarfs even the Common Berthing Mechanism. Other than that, it mostly looks like a scaled-up international docking adapter with all its bells and whistles. It has 3 petals for alignment and similar latches, actuators, and such. The adapter is also androgynous, meaning either half can serve as the active or the passive half, depending on the situation. Usually, the visiting vehicle takes the active role. Most importantly, it has a massive 2.9 meter opening. That will fit the largest pieces of equipment on the ISS and then some. In addition to allowing larger vehicles to dock, the system can even serve as the connection point between a space station module and the rocket it's launching on. Vast claims the large docking adapter is up to 30 times more rigid than the current international docking adapter. That might hint at one of the reasons why the company took up this project, as Vast is looking to build future space stations out of Starship-scale modules. And those stations are even meant to rotate for artificial gravity. As a result, the connections between those modules will have to withstand lots of force, which the relatively weak IDA might not be able to hold up to. You don't want your space station ripping itself apart. That would be a bad day in space. Now, we won't see this adapter fly on the small Haven 1 station, and we might not even see it on Haven 2, although that probably depends on how the company plans to adapt to NASA's revised program for a commercial ISS successor. Either way, Vast says it will open source the large docking adapter standard next month, so everyone with a spaceship can implement it. If others pick it up, it might very well become the go-to method for spacecraft to connect to future space stations. It's so great to see all of the mystery goo science points collected high above the moon on Artemis 2 are already leveling up the tech tree. It's been almost 2 years since Virgin Galactic pressed pause on its space tourism flights and announced a reset. As the VSS Unity completed its 17th and final mission in June 2024, the company announced it was drawing a line under its first-generation spacecraft. With 11 crewed missions under its belt, Unity had proven the concept worked, flying private astronauts to the edge of space roughly once a month. So why the reset? Well, at that flight rate, the operation simply wouldn't scale, and the revenue ceiling was too low to support a sustainable business. So the company took a step back in order to move forward. Missions aboard Spaceship 2 typically carried 4 passengers alongside 2 crew, whereas the company's new Delta-class spacecraft is designed to carry 6. With a more durable and less inspection-heavy design, Virgin Galactic also aims to improve the turnaround time between flights to days, not weeks, flying up to 125 times per year, roughly twice per week. To increase this launch cadence, the company has adopted a production line approach to building its vehicles in its purpose-built spaceship factory in Arizona. Here, the team are building and assembling its next-generation spaceship. We can see the first Delta ship is really taking shape on the factory floor now, as the wing and fuselage are prepared and integrated with the vehicle's distinct feather. Now that the first ship is nearing the end of its build, Virgin has reopened bookings for trips to space, which will fly, as they did before, from Spaceport America in New Mexico. This week, Virgin Galactic and Purdue University confirmed the full crew for Purdue 1, a 5-person, all-university mission set to fly in 2027. This is the first time a university has crewed its own space mission, in which a professor, a student, and alumni will carry out live experiments in microgravity.
This will be the first time that crew entirely from one university are in space on a flight working together.
Experiments on board will include a system for quantum navigation, positioning, and timekeeping in space that would be far more accurate than, and doesn't require, GPS. For now, space tourism has taken a back seat in more places than just New Mexico. Blue Origin similarly announced it would pause flights of New Shepard for at least 2 years following the NS-38 mission in late January. While the company described this as a strategic move to focus on lunar lander development, some have interpreted this as a potential cancellation of the project. So does this leave Virgin Galactic with the space tourism market to itself? While companies such as Space Adventures and Axiom Space have been sending civilians to the International Space Station since 2001, others have been preparing different ways of taking paying customers to the stratosphere using giant balloons rather than rockets. These longer, near-space trips would reach around 30 kilometers in height, much lower than the Kármán line, which is viewed as the edge of space by most, but with an experience lasting hours rather than minutes. Space Perspective completed an uncrewed test flight in September 2024, but was then acquired last year by Spain's EOS X Space, following financial difficulties, delaying their original plans to begin flights this year. Meanwhile, several companies in China are busy preparing to enter the market, with designs from the likes of Interstellar and Deep Blue Aerospace preparing for suborbital flights in the next few years. Interstellar has already begun to take reservations for flights starting in 2028, while Deep Blue used a live broadcast to sell tickets for its own debut mission, targeting next year, which reportedly sold out within minutes. These designs follow New Shepard in their general architecture, with a reusable booster separating from a crewed capsule. CAS Space's Lihong 2 is expected to take its maiden flight later this year. The company has already issued a call for experimental payloads for its first uncrewed mission. The craft will debut a 7-person capacity and a reusable lifetime of 30 flights. While it's taken a break for now, space tourism does look like an industry that's on the rise. Amazon made some big announcements this week about its internet constellation, LEO, which you might know for its previous name, dare I say much better name, Project Kuiper. First of all, the company is diving into the aviation market as it launched the Amazon LEO aviation antenna. You guessed it, it's for airplanes. It will fit on a wide variety of aircraft, ranging from small regional jets to large widebodies, and will provide connections with download speeds of up to 1 gigabit per second and upload speeds up to 400 megabits per second. That's over 3 times better than the median terrestrial speeds you'd find in the US. The antenna shares technology with Amazon's enterprise-grade Ultra Terminal, but incorporates some changes to make it aviation-grade. It has no moving parts and can be installed in just 1 day, so it shouldn't be a maintenance nightmare. The company already has agreements with Delta, who wants to install the antenna onto 500 airplanes starting in 2028, and JetBlue, which plans to start as early as next year. Whether they'll be able to eat into a market which already has tens of airlines signed with Starlink is still yet to be determined. The LEO constellation is still in its infancy, with only 241 production satellites launched. It's supposed to have well over 3,000 though. Amazon recently asked the FCC to extend the deadline by which they were required to launch half of the constellation to hold on to their frequency rights. That deadline was originally set for July. Even though Amazon is quickly increasing its launch cadence, it still seems like it might take a while before the constellation is sufficiently mature to offer internet to airplane passengers around the world. But Amazon certainly has big plans for the constellation, and this week they took an important step to make it happen. The company announced it has acquired Globalstar, and they're merging it into LEO. Amazon won't just take over existing satellite operations and infrastructure, but also spectrum licenses. That might be the most important part of the deal. Last year, we saw SpaceX buy spectrum licenses from EchoStar for an eye-watering $17 billion with a B. So yeah, it's not at all surprising that Amazon is also looking to obtain radio frequencies. They are incredibly valuable. There is another interesting part to this deal though. Globalstar has experience with direct-to-device technology, for which consumer devices like smartphones connect to the satellites directly. Amazon plans to deploy its own direct-to-device product in 2028, which the company hopes will offer faster speeds and better performance than legacy direct-to-cell systems. Much like aviation, we'll just have to wait and see how it holds up to Starlink's equivalent product. Good morning, Cupertino. There's one more thing. Amazon's agreement with Globalstar has also resulted in another agreement with Apple. Globalstar currently powers satellite services on iPhones and Apple Watches that support the SOS feature. Apple and Amazon have agreed that LEO will take over this feature. Despite the constellation's current small size, it appears that Amazon is gaining a strong foothold and could soon become a very serious competitor to Starlink. Now we'll take a look at some other stories across space, starting with even more spaceplane news, but this one is actually destined for orbit. The first Dream Chaser spaceplane, named Tenacity, has completed acoustic testing, marking a major step towards its maiden flight. Sierra Space has been testing the vehicle at the Kennedy Space Center's Space Systems Processing Facility. There, they surrounded Tenacity with speakers, which blasted the spaceplane with sounds similar to those inside the 5-meter payload fairing during launch. The spacecraft, which had its wings stowed as it would on the way up, made it out unscathed, proving it can survive the intense conditions during launch without problem. While this is an important milestone in the Dream Chaser program, the spaceplane's long-term future is still all but certain. Following a series of delays, NASA restructured its contract with Sierra Space last year. This effectively downgraded the contract, scrapping a guaranteed ISS resupply mission and also changing the profile of the first flight so it wouldn't visit the orbital outpost. That mission might launch as soon as the last quarter of this year, and I sure hope it does. We like spaceplanes over here. NSF was founded to cover the space shuttle after all, and we definitely want more of them in the future. Its launch vehicle is ready, right? Right? Another vehicle rapidly taking shape in the factory is Relativity Space's reusable Terran R. Integration is now fully underway across the primary structures, with mechanical assembly now closed out on both of the propellant tanks. Acceptance testing has begun on the Stage 1 downcomer, don't at me Jack, that's what Relativity calls it, which is now fully welded, while hardware in-the-loop testing is now ready to verify and test software for the vehicle. All trays are now installed on the thrust structure ahead of engine integration. Those Eon R engines continue to roll out of the shop and conduct their own acceptance testing at NASA's Stennis Space Center, where the second stage vacuum engine has conducted a 525-second endurance test. Relativity is really ramping up its hardware production in Long Beach now, adding a second circumferential friction stir welder, more CNC machines, and powder bed fusion printers. The company reports that they have over $3 billion worth of a payload backlog for the vehicle, ranging from commercial to government clients, including Intelsat, SES, and Eutelsat OneWeb, each of which has contracted the company for multiple launches of their satellites. The payload aboard Terran R's first mission is yet to be announced, but work continues at the Cape's Launch Complex 16, where it will take to the skies for the very first time. The transporter Erector Strongback is now being outfitted, while the rails that will roll it to the pad have begun installation. Propellant tanks are now in place, the water tower is on the rise, and the lightning protection system will soon follow. Things are really coming together now as we look forward to seeing Terran R on the pad later this year. And while we're on the topic of launch pads in Florida, we reported last week about growing launch facilities there for Blue Origin's New Glenn. We'd spotted some official filings naming New Glenn in plans that would expand Launch Complex 36 into neighbouring Launch Complex 11. While Blue Origin still hasn't officially announced any plans for a second launch site at the Cape, it has officially been chosen for a different launch site on the West Coast. The United States Space Force has chosen Blue Origin to move forward with lease negotiations for the undeveloped Space Launch Complex 14 at the Vandenberg Space Force Base in California. This will be a significant step towards becoming a bi-coastal launch provider and enables Vandenberg to build out heavy and even super heavy lift launch capabilities as the base expands its role in national security space operations. If finalised, the site would provide New Glenn with access to polar and sun-synchronous orbits that aren't reachable from Florida. Blue Origin was one of several providers assessed for the greenfield site, but there are still some hurdles ahead. Environmental reviews, safety assessments, and infrastructure work all need to be completed before any construction or launches can begin. We'll be keeping an eye on this, so if you want to stay in the loop, that subscribe button might come in handy. Also, to clear things up, this Slick 14 is a different Slick 14 from Stoke Space's Slick 14. That Slick 14 is in Florida, this Slick 14 is in California. Elsewhere in California, Impulse Space is progressing with its Helios space tug. Now, if you remember, the company was founded by Tom Mueller, who you might know as the designer of SpaceX's legendary Merlin engine. His new enterprise focuses on in-space mobility, or moving payloads between orbits. Helios is a kick stage designed to quickly transfer satellites from low Earth orbit to geostationary orbit. This helps get satellites to their destination orbits much quicker, without requiring an oversized rocket to get the job done. Helios is quite a versatile spacecraft though, as it can also go to the moon, and even beyond. It's powered by Impulse's own Deneb engine, which runs on liquid oxygen and liquid methane. It can restart, which helps with the craft's versatility by allowing multi-burn missions. Images released this week show Helios in the factory. It doesn't yet have an engine or payload adapter, but they seem to be making good progress with it. One thing that does stand out though, and I'm trying to be polite here, but it does look a bit more puffy than it does on Impulse's renderings, and there's a lot of tape on the vehicle too. It could just be a bunch of insulation material with tape sealing up the gaps. That would certainly explain the look, but without official confirmation, it's hard to know what exactly we're looking at here. We love these updates though, so it's always great to see actual hardware instead of animations, and we're sure looking forward to seeing a completed kick stage. Returning to space stations for a moment, NASA has selected a new company to send private astronauts to the International Space Station. The agency has awarded its 7th private astronaut mission to Voyager Technologies, with a mission known as VOYG-1 set to launch no earlier than 2028. The reason I said it like that is because I'm not 100% sure how it's meant to be pronounced. Voyage 1? Voyager 1? Why don't they just call it Voyager 1? Oh. Like previous missions, it will carry 4 private astronauts for a roughly 2-week stay aboard the station. But this isn't just another commercial crew rotation. For NASA, these missions are part of a broader plan to hand over operations in low Earth orbit to private industry, creating an environment where the agency becomes the customer rather than the operator. Voyager is currently developing the Starlab commercial space station with Airbus, and this mission effectively gives the company a chance to rehearse a series of operations from crew training to mission control. Starlab passed its commercial critical design review with NASA in February, and is likely to launch no earlier than 2029 before the ISS is retired. The station is in the early production stages and will require a Starship to loft it to orbit in a single launch. Like Vast Haven 1 discussed earlier, the station will hold a crew of up to 4. Until now, private astronaut missions to the ISS have been largely dominated by Axiom Space. VAST was awarded the 6th private astronaut mission in February. With Voyager now joining the mix, NASA is widening the field of commercial providers as it helps to build whatever comes next. Let's talk about the first A in NASA, as their X-59 aircraft took a giant leap. Recently, the experimental aircraft flew with its landing gear up for the very first time. Now, that might not sound that important, but experimental aircraft usually take small steps in their first flights. So to begin with, they tend to fly with their gear down. It's safer that way, even if it looks a bit silly, because you'd rather have your gear down and not be landing than be landing and not being able to get the gear down. But the X-59 is supposed to be a supersonic aircraft, and it definitely won't make these speeds with its landing gear deployed. Now that it's cleared to fly with its landing gear up and stowed away, we can admire the sleek design in all its glory. The airframe is specifically tuned to reduce sonic booms into a quiet thump, so supersonic flight isn't so disruptive to the people on the ground. With the recent milestone passed, NASA can start characterizing the aerodynamics and see if the concept actually works as intended. To electric propulsion, Rocket Lab has unveiled a new spacecraft thruster, and they named it Gauss after the famous German scientist. The new thruster is an electric propulsion system, and besides looking very futuristic, it's very efficient technology. Or in spaceflight terminology, it has a higher specific impulse compared to traditional chemical engines. The flip side is that electric propulsion is very low powered, but as long as you don't need to go anywhere fast, that's a worthy trade-off. Gauss runs on xenon propellant, but Rocket Lab states it can also run on krypton. The company has already established a production line to make more than 200 of them per year, and envisions the system being used for satellite constellations. Rocket Lab isn't just a rocket company anymore, and they haven't been for a long time. Through its many acquisitions, it now has a diverse offering of different satellite parts, and they just keep expanding. This week, they also added laser communication systems to the mix with the purchase of German company Minarik. The companies have been in talks to make it work for a long time, and now the deal is finally finalized. So, if you want to build some satellites that are powered by electric thrusters and communicate through lasers, it seems Rocket Lab is now your one-stop shop. Oh, and pick up some solar cells on your way out. This is your weekly space traffic report brought to you by Next Spaceflight, starting with a launch that just missed last week's traffic report. China launched a Zhelong 3 on April 11th from the Dongfeng-Hung Tiangong barge stationed in the South China Sea. The payload on this mission appears to have been a test satellite for the state-owned SatNet Internet constellation. Later in the week, a Kinetica 1, also known as a Lesion 1, lifted off from Zhouchen to launch a batch of Earth observation satellites into sun-synchronous orbit. The 8 satellites join the Zhilin 1 commercial Earth observation constellation. Lots of Asians this week. Zhouchen saw another mission near the end of the week, with a Changzheng 4C lifting the Atmospheric Environment Monitoring Satellite, also known as AEMS, into a sun-synchronous orbit. Just before, we had a surprise Soyuz launch from the Plazets Cosmodrome in Russia, specifically in its 2.1B Volga configuration. Unfortunately, we have no idea what was on board right now. It looks like it was one of those secretive military government payloads. Meanwhile, SpaceX launched 2 Starlink missions this week, one from Florida, the other from California. Next week, the company plans to fly 2 more Starlink missions, both from California's Vandenberg Space Force Base. Over at Cape Canaveral, they're also set to launch the GPS-3 Space Vehicle 10 satellite. The spacecraft was originally set to launch on ULA's Vulcan, but considering the repeated SRB nozzle failure alluded to earlier, it was moved over to Falcon 9. Also at the Cape, Blue Origin is getting ready to launch New Glenn's 3rd mission, and the first one to reuse a booster. Following some refurbishment, Glenn Stage 1, Never Tell Me the Odds, gets a second chance to fly and loft a Bluebird communication satellite for AST Space Mobile. The booster already proved itself during a static fire yesterday. It ignited its 7 BE-4 engines for 19 seconds. Blue seemed rather confident in the booster, as it had fully integrated the rocket with the payload on top before rolling it out to the pad. Interestingly, this was an entirely new complement of engines, featuring some upgrades over the ones installed on the booster for its first flight. CEO Dave Limp told NSF's Max Evans that the original engines will get another chance to fly on a future mission. If all goes well, Never Tell Me the Odds should reignite its current engines for liftoff no earlier than April 19th, followed shortly after by a reignition for its entry burn, which will be followed shortly after by a reignition for its landing burn. Moving up the US East Coast to Virginia's Wallops Island, a suborbital haste version of Rocket Lab's Electron has been spotted. The mission shows up on flight restrictions under the quirky name Bubbles. I mean, Rocket Lab names are out there, but Bubbles. The company also plans to launch a regular full-fat Electron from its spaceport at New Zealand's Mahia Peninsula. The mission, named Kakusin Rising, will loft 8 small satellites for Japan's space agency, JAXA. Over in South Korea, we might see the first orbital test flight of the country's new military small satellite launcher. A few years ago, the solid-fueled rocket flew a couple suborbital missions, and it now seems ready to demonstrate its orbital capabilities from an offshore launch platform near Jeju Island. Finally, the Progress MS-32 cargo resupply craft is set to depart the ISS after a half-year stay. Last week, the spacecraft ignited its thrusters to boost the station's orbit, preparing for the arrival of the next Progress vehicle, which is set to launch later this month. To make room for that arrival, Progress MS-32 will undock from the station on April 20th and take out some trash in the process. As always, the schedule is flexible and is subject to change. Even more launches might pop up. Want to stay in the loop? Check out our next Spaceflight app and website for the latest updates. For now, I've been Caton for NSF, thanks for watching, and goodbye.